Hello, we are back with some more stoichiometry problems. This is extra practice problem number 4 for stoichiometry chapter 6. So let's get right down to it. Let's make our roadmap for what we're doing here. We've got carbon tetrachloride is made according to the following reaction. We've got CS2, 1 mole of it, plus 3 moles of chlorine, the diatomic atom there, or compound rather, yields CCl4 plus 1 mole of S2Cl2. All right, remember, each of these that don't have a number as a coefficient, we're just 1 is what's in front of it. All right, so what they want to know is how much CS2 is needed to make 16 kilograms, let's make note of that, it's not grams, of CCl4. All right, so they have given us grams of CCl4. All right, and ultimately this how much is how many grams of CS2. So using stoichiometry, we have to get our grams of CCl4 into moles of CCl4. Then from moles of CCl4, we can get, using our balanced chemical reaction, moles of CS2. And then at that point, we can get into grams of CS2. All right, we have done enough of these problems to know that we are going to need the molecular mass of these two things we're talking about. So let's go ahead and knock that out, shall we? So if we're going to get the molecular mass of CCl4, let's go ahead and figure out what our molecular mass is. So you've got 1 atom of carbon, 4 atoms of chlorine. So when we look at that, we know that we've got 12.01 for our carbon, and chlorine is 35.45. Okay, when we multiply those out, well, that math on 12.01 isn't that hard, right? We get 141.8 on the chlorine. We add those together, and that gives us 153.81 AMU. We are, remember, significant digits. We're going to stop at the shortest, or at the place of your addends that is the smallest number of decimal places to the right of the decimal point. So here we're going to lop it off right there. So we're actually going to have 153.8. All right, and that's atomic mass units, or we could think about it in terms of the conversion factor. So you could say 1 mole of CCl4 is 153.8 grams of CCl4. Okay, let's go ahead and get CS2 out of the way. We've got one atom of carbon there and 2 of sulfur. So carbon, 12.01. Why don't I remember sulfur off the top of my head? Let's look, 32.07. I don't have them all memorized either, people. Sometimes some of them come more frequently, so you memorize those. All right, so what you get there is 12.01. 2 times 32.07 is going to give you 64.14. We're good on those decimal places. And we're going to get 76.15. And again, that's atomic mass units, or molecular mass units, depending on which resource you're looking at. And that's another way to say that in terms of our conversion factors is 1 mole of CS2 is equivalent. We would have, oh goodness, what am I doing there? 76.15 grams of CS2. Okay, and we're going to use that in just a second. So hopefully you're writing this along with me. All right, back up to the top over here. All right, now I'm going to just do this all as one bracket, and I think you guys can keep up with me. You can break each step up into its own bracket if that makes you happy. All right, but let's go ahead and try and do this together. The problem says that we start with 16 grams of CCl4. So that is where we are going to start our math. All right. So we have 16 kilograms of CCl4. All right. Well, I know my what I did over here. I'm going to have a ratio of grams to moles. So let's go ahead and get rid of kilograms. We know that 1 kilogram of any substance, I'm just, because I like to keep things neat, would equal 1,000 grams of that same substance or any other substance. But just for our canceling our, canceling our labels, I'm writing it this way. So kilograms gone. I've got grams of CCl4. Fantastic. All right, looking at our roadmap, grams of CCl4 is where I'm going to start this stoichiometry journey. I don't think some of you are excited to be on the journey with me, but here we are. All right, so we've got grams, and then we are going to say, all right, we have that conversion factor. We just figured out the molecular mass of CCl4 in terms of grams, and we know that 153.8 grams of CCl4 equals 1 mole of CCl4. Okay, that's the quantity, the molar quantity. So, and then the mass is on the bottom. That's how they relate. That's their definition. All right, so now we've gotten rid of grams of CCl4. We're here at this step. We're at moles of CCl4. All right, so we know that I should have kept it over here. We know that looking at our balanced equation, 1 mole of CS2, for 1 mole of CS2 you put in, you're going to yield 1 mole of CCl4. Oh, that's such nice math. I like it when some things are easy. All right, so I know that when I have 1 mole of CCl4, I'll have 1 mole of CS2. All right, fantastic. Back to our roadmap. We got done with this guy. Now we're at moles of CS2. We need to get to grams of CS2, and that's where we're going to use this one down here. All right, we're going to have to invert it because we're going to want grams on top. So looking back at this, come on. All right. There we go. All right, so we know that for every 1 mole of CS2, from our molecular mass, we can say that that is 76.15 grams of CS2. Now all we need to do is the math. So you are going to multiply everything on the top and divide it by the product of everything on the bottom, and that is going to give you your answer. And in this case, when I calculated it out, I got 7.6 times 10 to the third grams of CS2. Okay, again, you can totally make this separate steps. You can say, all right, well, I'm starting with 16 kilograms. I'm going to convert it to grams, and that's my first step. And then take that answer and move on to the next step and apply that. If that is easier for you to mentally order, please do that. But the key thing is follow your roadmap that you know, and I remember I gave you guys a little flip chart to try and help guide you along this process. So however it helps to get this firmed up in your head, do that. But all of the steps need to be present in order to get you back over to grams of CS2. All right?